to Gaetan and all the seminar organizers for inviting me and having me here today. It's a really great opportunity to present my research and obtain useful feedback, and a special thanks to Adam Jaffe for agreeing to discuss this. I really look forward to your feedback. And so to give some background to this paper, it's research that's being somewhat long in the making. It's a project that I started about more than a couple of years ago now, together with a friend and co-author, Tanner Reagan. And then what I'm presenting today is sort of a spin-off or an extension to the initial research we did together. So if you hear me during the presentation speak in first person plural a lot, it's because I'm greatly indebted to Tanner also for the extensive conversations we had about this project and support throughout. And of course, all errors and mistakes are entirely my responsibility. Okay, but just so to briefly give you an overview of the project before going into the details of it, the question that I'm asking is whether stronger informal social ties across places raise knowledge flows. And by knowledge flows, the focus is on technical and scientific knowledge as embedded in patent citations. And the focus is also on flows across places rather than localization within a specific geographical unit. In this case, I'm considering counties in the US. The other thing to emphasize is that I'm looking at informal social ties. By doing so, I'm hoping to kind of get closer to a definition of knowledge as a thing in the air, going back to what Marshall was discussing. In order to achieve this, I need to control for other potentially and indeed relevant mechanism, and specifically the role of professional networks. But for informal social ties, I think one of the added values of this paper is to exploit a new measure, a direct and broad measure for social interaction that allows to study flows across the entire geography of the United States. And the motivation behind this research stems from the quite strong positive correlation observed between the propensity of two counties to cite one another and how strongly social connected they are, here represented on the x-axis in both graphs. And I'm going to say a few words about the measure I use in a moment. And this holds true irrespective of whether I consider the log of just the citation counts for the citation share between any two county pairs, or the rate, which here is closer to and more consistent to the identification strategy used in the paper, which refers to essentially the propensity of a patent to cite, to include citations added by an applicant as opposed to by an examiner. And so the objective of the paper is to take a closer look at this correlation, unpack it, and see whether it can, whether it's revealing something about a true relationship between these two determinants of knowledge flows. And to give you a preview of kind of the empirical approach and the results, as I was saying, in terms of data and measurement, the measure of knowledge flows is patent citations, as captured by citations included on the US Patent Trademark Office Patent Field database. And for social connectedness, we use a newly available measure, which is based on Facebook friendships. And this was obtained from Facebook. In the scope of the analysis is the United States between 2016 and 2019. And the idea, as I was mentioning earlier, our empirical strategy is to exploit information on the source of every citation that we observe, whether or not it was added by an examiner or by the applicant him or herself. This is available from 2001 onwards. And so we compare, in the empirical analysis, we compare the applicant citation to those added by the examiner in a linear probability model. where a dummy of indicating the source of the citation is regressed onto a measure of social connectedness, also controlling for geographical distance, and then a measure of professional inventor networks. But I'm going to get into more details about the empirical model in a bit. And to preview the findings, I uncover a small but significant and quite robust effect of informal connections or social connectedness. I'm going to be using these terms interchangeably in what follows, on the probability of two counties to cite one another. And we also show that the magnitude of the effect that we uncover somewhat depends on circumstances. We find that it has increased over time since 2002. And it also matters twice as much for what we term garage inventors or entrepreneurs or newly patenting assignees, essentially. And it's also, it tends to be stronger for knowledge that has become common domain in a geographical sense. I will explain this more in detail. And for more distant technologies. We also look at changes across different discrete geographical boundaries, but find no effect for any boundary effects, or we cannot conclude much about substitution potentially with geographical forces. Okay, so to just discuss the conceptual framework a bit more in detail, the interest here indeed is in the role of kind of this informal type of social connectedness in the exchange of ideas. And if we take what's already known in the literature, we know, starting with the seminal paper by Jaffe, Trachtenberg, and Henderson in '93, that knowledge flows indeed tend to be localized, and the propensity to exchange knowledge and to innovate increases with population density. And then we also know from a later paper by Breschi and Lissoni in 2009, the Journal of Economic Geography, that localization seems to be largely determined by the fact that inventors' mobility is constrained in the geographical space. In addition, the same authors also document that there seems to be a tendency for professional ties, close professional ties, to prevail over more informal ones. And in this paper, the authors define informal ties essentially as a decay in the degree of connections over the professional network. And so the point of departure is that we believe this picture is I mean, we're by no means attempting to deny this picture, but we are attempting to add some dimensions to this because it's potentially incomplete. In particular, because of if we consider the exchange of knowledge locally and informal ties locally, the literature considers the role of density, but indeed this is only informative about local interaction, whereas it's possible that social connections and these informal type of social connections matter also when they're not geographically close. And we have an opportunity to measure them in this paper. And second is the fact that professional networks might, or knowledge exchanged via professional networks might be discipline bias, precisely because of the nature of these relationships. And so perhaps by studying an informal type of measure of interaction, we might find that it leads to exchange of a different type of knowledge or a more diverse set of ideas, something we'll be able to say a little bit about in our analysis of heterogeneity and the effects we study. Finally, there is very little, if no evidence at all about, or direct evidence about informal interaction, as I was saying, outside one's own region. So the focus here is to really study its role in providing access to external sources of knowledge, so beyond one's own local environment. And just to clarify a little bit more why we might expect informal types of relationships to matter, it's useful to distinguish between heavy and light knowledge conveyors, distinction that was that I owe to a comment by Francesco Lissoni. And here, the focus is on light knowledge conveyors. Again, going back to this idea of knowledge as if in the air, and we can think of a knowledge being obtained via chance meetings, so serendipitous encounters, referrals from friends of friends over informal networks, And a second possibility is that these informal types of connections give exposure to different markets and give salience to certain opportunities in those markets, which in turn drives kind of the type of knowledge that's exchanged. And we're interested in isolating this from more heavy type of knowledge conveyors, which would be related to the professional network of inventors or to the mobility of inventors themselves. And so in order to do this, we need to be able to control for these connections, and we'll do so by relying on co-inventor networks. In doing so, this paper dialogues with three broad strands of literature that have considered knowledge flows. One in urban economics and regional science that looks specifically on the effect of agglomeration economies. I've included a number of papers here. This is by all means not a comprehensive review. The article by Caroline and Kerr in 2015 provides a detailed overview of this literature. And the second strand is the one on economics of innovation, or more specifically, all research that looks at patent citations as a measure of knowledge flows, starting with a seminal contribution by Adam Jaffe and colleagues in '93. And this literature was recently reviewed by Jaffe and Rasenfos in 2017, with an emphasis on discussing the opportunities and potential pitfalls of dealing with patent citation and patent data more in general. And finally, the aim is to contribute to a specific substrand of this literature that then considers the role of collaboration, inventor networks, and social interaction, notably by focusing on this informal type of knowledge exchange that for which there isn't much evidence yet in the literature. I should mention there is one paper by Michael Bailey and colleagues published in 2018 in the Journal of Economic Perspectives that introduces the same measure that we rely on in this paper, and among other relationships also considers the role on patent citations. The objective and the intended contribution to this paper would be really to narrow down and zoom into this specific relationship with knowledge flows and bring it to further scrutiny, study it with a new identification strategy, and to document some potential sources of heterogeneity. Okay. Just a few words on the data we use. I've already mentioned it partly. Our main explanatory variable is the social connectedness index, which we obtain from Facebook, and essentially measures the graph for the universe of active US Facebook accounts, a snapshot that was taken in April 2016. Unfortunately, we don't actually observe the microdata. This is all aggregated at county level and rescaled. So for every county, we have a number that relates to the number of friends this county has with all other counties in the US. So we essentially have an undirected weighted graph of about 3,000 nodes representing counties and over 9 million positively valued edges. And just to say a few words about how to think about these Facebook connections, we think of them as one of the most comprehensive revealed measures of social interactions that are available out there, especially for the entire geography of our country. Facebook users in 2016 were about 220 million. Subsequent research places in 2016 about 70% of American adults as using Facebook, and the users tend to broadly be representative of the general population. I think younger people tend to be somewhat overrepresented, and so I believe do women. But then research does show that interaction over Facebook tends to reflect real life connections, and that Facebook is a helpful measure in predicting the strength of a tie in occurring in real life. So really for us, this is a proxy for kind of social interaction occurring across the entire United States. And on the outcome side, we obtain data on citations from PatentsView, which is a large structured data released from by the USPTO on the population of patents issued since 1976. And as I was saying, from 2001 onwards, we also have information on the source of every citation, whether or not it was added by the applicant or by the patent examiner. And the set that we focus on is based on all the citing patents issued between 2016 and 2019. And we restrict to US located inventors only, whether on the citing or on the cited patents side. And we match each patent onto counties based on the modal inventor location. And in previous versions of this paper, we also considered assigning it, as is done in some other papers, to the first available inventor with very similar results. In addition, we performed some sample restrictions. We dropped the top 5% of citing patents in terms of granting time, so the elapsed time between application and issue date, because of potential unobserved heterogeneity and patents that took a long time to issue. And we do a similar trimming for cited patents that are extremely old at the time they were cited. So here we consider the elapsed time between the application dates. And the resulting data set is composed of roughly 500,000 patents, sending over 11 million citations, of which roughly 60% on average are added by the applicant, the patent applicant, him or herself. And on top of it, we also have a separate sample that's constructed in a similar way, but that retains a 20% stratified random sample for citing patents issued between 2002 and 2019. And this is because we're interested in studying heterogeneity of effects over time to document whether or not the effect or the relevance of social connectedness has become more or less relevant. All right, and as I was saying, it's also important for our research to really be able to kind of emphasize the role of informal connections to control for professional inventor networks, which otherwise might just be picked up with a lot of noise by our measure of social connectedness. And so to this end, we construct a network using all available inventors on all patents. So this includes patents also outside the US to make sure that there aren't any unobserved links. And we rely on disambiguated inventor IDs, which are available from PatentsView directly based on their own disambiguation algorithm. And I should say we do not attempt to validate this. We take the inventor IDs as they are. And due to computational feasibility, we can only focus on we can only construct a measure up to the second degree of connection. So just to clarify, if we observe like a bipartite network connecting inventors in the nodes in blue to patents here in gray, projecting this bipartite networks onto inventors, we observe, for instance, the quartership links between A and B. So this will be a degree 1 connection. And then between A and F, this will be the quarter of a quarter, so the second degree connection. When we project this network in panel A onto patents, essentially we obtain the measure that we control for when we observe a citation between two patents. So the existence of one link on the patents is reflected by the fact that two patents might just have a common inventor, a common author. 2 degrees here reflects the fact that there is one shared co-author, and patent 2 here and patent 4 will be the maximum degree we can control for, which is essentially the co-author of a co-author, in this case B or F through B for A. Okay, and then we can visualize our main 2 variables of interest. In this case, I'm mapping the top 1% of connections in terms of strength in the SCI measure in 2016, and the links between the major US cities is apparent in this. But more interesting is to overlay the map of the top 1% of citations sent and received from each county pairs. And again, the correlation between those two measures is striking, except perhaps that people seem to have an interest in sharing friendships with people in Florida, not so much in sharing knowledge with them. Perhaps friends with a nice house in Florida is an unrelated benefit to this. But so, as previous papers in the literature, we face an identification problem stemming from the fact that industries tend to collocate for reasons not necessarily just related to learning or knowledge diffusion and spillovers, but which might also be related to sharing or matching using the labels introduced by Duranton and Puga in 2004, for instance, because there are indivisible inputs or some gains from variety and intermediate inputs, or in terms of matching because of thicker labor markets. This is true for the geographical space, but it's also true in the social space. And here the identification concerns are outlined very clearly in the work of Mansky in 1993 and 2000 in terms of correlated and contextual effects. We might think that connections are established between similar people due to homophily and sorting into relationships. For instance, if engineers like each other and tend to socialize with each other, then it might just be that places that disproportionately have engineers in their population will tend to cite each other, but for reasons unrelated to the fact that there's actual interaction there, but simply because independently there's interaction, and then that's also where the relevant knowledge is created. Similarly, there might be common unobserved environmental factors. This could be, for instance, the case between Stanford and Cambridge. If at MIT and at Stanford, we observe a population of students interacting with each other and therefore establishing this kind of informal social connection. But at the same time, both institutions also hosting research centers and researchers and producing knowledge. In this case, we could observe the two places to cite one another because the relevant research is produced there, but without this being necessarily tied together with the interaction, which is then spuriously identified. Lastly, and trivially in part, it's a measurement concern because we impute and we define social connectedness based on the location where the inventor lives or works. And so the idea is really to think of social connectedness as this kind of informal social environment that the inventor is exposed to daily, and how this connects him or her to other places or knowledge produced in other places in the US. And so we really face the same set of issues documented for research that focuses on geographic localization. And there are also some additional concerns, for instance, varying propensity of counties or specific patterns to cite or to innovate. There might be also effects pertaining to certain technological classes or pair of technological classes, and also then just a matter of what exactly social connectedness is capturing, and whether or not it potentially is just picking up past migration flows between places. So these are the things that we have in mind when devising our identification strategy, which we essentially borrow from Peter Thompson in an article in 2006. The idea is to compare applicant citations to a control group formed by examiner-added citations. And so we compare levels of social connectedness in one case against those in the other. And the required assumption, without going into too much detail here, is that essentially knowledge flows need to be more likely to occur for applicant-added citations or for applicants than for examiners. And then importantly, we need to think about citations added by examiners as being orthogonal to the geographical space or the social space. Or in other words, examiner, in the case of social networks, shouldn't tap into their own social network in order to learn about prior art, which would expose us to the same set of potential biases that I was describing earlier. And there is some support for this identification strategy based on the applicant side, based on the fact that there's a duty of candor requirement. So applicants are required to disclose any prior knowledge that they had when applying for the patent. And on the examiner side, it's helpful that all examiners work from one campus in Alexandria, Virginia, at the USPTO headquarters, which should ensure the orthogonality of the geographical or social space to the extent that it's imputed based on geographic location. And this can be tested in some way. In this case, I reassign for control citation the distance and the social connectedness to the set of citations added by the examiner, as if they had been added specifically by from Alexandria and Virginia. And so we can compare the line in green and the distribution of these connectedness strengths and distances to that we observe otherwise for the applicant added citation in blue, or the control group without implementing the substitution. And so what we see essentially is that focusing on the social connectedness, it doesn't seem that examiners tend to tap into their own social networks from citing, but rather, if at all, from that of the applicant him or herself, which is presumably because of these localization effects, and the fact that these distributions track each other speaks in favor of it being used as a control group. Okay, and then the idea, as I mentioned, is to implement this this identification strategy into a linear probability model by regressing a dummy, which captures the source of citation, whether it was an applicant, which we code as 1, or by an examiner, which is coded as 0, onto a measure of social connectedness, of geographical distance, and of professional inventor networks. So this captures whether or not there was the same shared author, co-author, or co-author of a co-author. And on top of it, we include a vector of bilateral county level observables. We focus on differences in a number of characteristics. And we also consider citing and cited patent fixed effects, and citing and cited patent, county fixed effects, issue year cohorts. In this case, we consider technology pair fixed effects using 35 WIPO fields. We also, in further checks, include citing and cited patent fixed effects, which, however, we believe might be too restrictive. And then finally, just to mention, we allow for multi-way clustering of the standard errors by citing and cited commuting zones to account for any kind of potential spatial correlation in the error term. Okay, and so to give you an idea of our results, here in columns 1, 3, and 5, I report the raw correlation between social connectedness, distance, and professional networks, and the outcomes. So the propensity of a citations to be added by the applicant as opposed to the examiner. And in columns 2, 4, and 6, I restrict to cross assignee and cross county flows. Indeed, because we are interested mainly in this kind of exchange across places rather than within. And on top of it, we include the set of dummies for citing and cited counties, citing and cited year cohorts, and the WIPO pair fixed effects. And in all cases, we observe a positive and significant correlation, positive as would be expected in the case of social connectedness, denoting that two counties that are more strongly connected will tend to share more knowledge. It's the opposite in the case of geographical distance, and again, a positive correlation in the case of professional networks, or a positive effect. In column 7, we control or we estimate all these three jointly. Interestingly, while social connectedness and the professional networks remain significant, geographical distance doesn't appear to play a role, perhaps suggesting that we do a better job at capturing cross-county knowledge flows by studying social connectedness and professional networks. I should also say in column 7 here, the dummy and professional networks, and specifically the part that controls for two patents having the same author, combined with the fact that we focus on cross-county and cross-assignee citations, indirectly also allows us to capture inventor mobility, because this will essentially entail that we are observing an inventor who crossed a county and now works for a different assignee. So this is how we interpret it. And so in column 7, we are comfortable interpreting this coefficient as capturing these kind of lighter knowledge conveyors that I was discussing before. In our main set of regressions, in column 2, we include the bilateral controls I was mentioning. Notably, we look at gross migration between any two counties in the previous 5 years, whether or not the two counties both shared one of the top 50 colleges in the US. And we also look at differences in education, inventor density, population density, income, and ethnic composition of the counties. And the coefficient remains positive and significant, and it remains positive and significant also once we include citing county fixed effects, or even citing and cited county fixed effects, even though it is much reduced in scope. Our preferred specification remains that in column 2. In column 5, we repeat the same specification, but in addition, we include a set of main effects for the potential drivers of heterogeneity that we'll investigate later, to ensure that we always retain the same intercept, and we are effectively just breaking down this coefficient here, which is very much aligned in magnitude to the one in column 2. And to give you an idea of the magnitude and relevance of these effects, if we move two counties from the lower to the upper quartile of social connectedness strength, these two counties will tend to, the probability that these two counties cite one another increases by about 1.2 percentage points. So indeed, not a very large effect, but one that's economically meaningful, because this occasionally might just entail, so this movement from the lower to the upper quartile might just entail crossing a border. So in this map here, where I draw connections for Santa Clara, or connections of all counties to Santa Clara County in California. In this map, I showed in green counties that are connected below the 25th percentile in terms of strength, and in blue, the ones that are connected at least to the 75th percentile in terms of strength or above. And there are many instances where these differences really occur between county borders, or anyway, quite closely in a geographical sense. So this change is a meaningful one. We also implement a number of robustness checks. For the sake of timing, I'm not going to go through them in detail, but just to emphasize that one important concern was that potentially we were imputing the location to patents erroneously. And so in column 3, we retain only patents that are single authored, for whom the geographic location is assigned correctly, necessarily. And even though the sample is much reduced, we still observe a positive and significant effect, perhaps slightly greater, suggesting maybe that single authors might rely disproportionately on social connectedness, although I don't think that we can distinguish it statistically. We can look at how the effect changes over time using the other sample I was mentioning earlier, and we observe indeed that it increases over time, which aligns to previous research that documents the increased importance of geographic collocation over time. So this is perhaps because knowledge has just become harder to find, as some recent research has been arguing. And so social connectedness might perhaps help in this process. I should also say this could also potentially simply be that our measure of social connectedness becomes more relevant or more accurate as we move closer in time. And then before concluding, just a few words about the heterogeneous effect we look at. In one case, we explore whether there are differences across geographical boundaries. If there are, and if perhaps social connectedness became more important at greater distances, then we could say something in terms of potentially complementarity of substitution between the two. We also consider elapsed time to citation, essentially the patent age at the time it was cited, to study whether or not perhaps younger patents are less known or old patents get forgotten, and if social connectedness might play any role in mitigating this. And we also consider the maximum assignee age, because we're interested in documenting whether or not perhaps social connectedness matters disproportionately for young inventors or first inventors or entrepreneurs, consistently with what density would do in the model, for instance, of nursery cities developed by Duranton and Puga. And then finally, we want to study whether it matters more for more unconventional type of combinations of knowledge. The impact of density was discussed recently by Berkes and Gaetani, and here we're interested in seeing whether or not informal connections perhaps also contribute bridging between different inventor communities. Without going into the details of the model, essentially what we do is we break down the effect of social connectedness each time and of distance as well by certain dummies, and we control for main effects.
And Andreas,
yes.
Sorry, just one clarifying question from Ling.
Mm-hmm.
Ling, maybe you want to ask directly?
Thanks, Gabriela, and thanks, Andreas. So I have a clarifying question regarding the data, which I might have missed in the beginning. So I know from patent's view that the sources of citations could be unidentifiable for some patents, even after 2001. So how did you deal with those citations? Did you group with either like examiner citation or with applicant citation? Or did you just drop them?
So there were some patents with missing information before 2012, but it was pretty consistently available after 2012. For anything before 2012, I think there was in some cases availability for citations added by other actors, but comparing also the frequency of these other added citations or this leftover category in the majority of cases, also for subsequent years, any actual other source of citations was mainly again the applicant. So before 2012, we assigned those missing ones to the applicant whenever we observed that they're added by other in general. But indeed, there is some assumption there which could potentially add noise to our estimates. I hope this addresses your question.
Okay, thank you.
And so just to restate on when we look at heterogeneity, we essentially just break down those coefficients that I showed earlier by interacting them with these drivers that we're interested in. In terms of geographical boundaries, we don't find any effects of heterogeneity. Geographical distance remains insignificant across geographical boundaries, whether or not it's within the own commuting zone, within the own state, but across the commuting zone or across state, whereas social connectedness remains positive and statistically significant. Perhaps in both instances, our measures become more precise as we move out in space, but we cannot really say much in terms of border effects, boundary effects, or substitution or complementarity. With respect to the age of the cited patent, geographical distance gives a picture that's consistent with the previous research on geographic localization, especially for younger patents. Being located close to each other is very important because as distance increases, the propensity to be cited decreases. But then as a patent gets older, knowledge diffuses and it becomes, in a geographical sense, kind of available. And this, in quite a striking synchrony, is the time when social connectedness seems to become relevant, perhaps biasing or favoring access to certain sources of knowledge as opposed to other, conditional on that knowledge being available in a geographical sense. In terms of assignee age, so we break this down by the maximum observed assignee age in the data. We see that at time 0, so essentially the first invention that an assignee has, social connectedness matters nearly twice as much as across the rest of the time, whereas we don't observe this for geographical distance. So perhaps this tells us something about a potentially entrepreneurship enhancing role of social connectedness. And just to conclude, in terms of technological distance, even though with some noise, we do observe a positive trend whereby pattern pairs that are farther away in the technological space tend to rely increasingly on social connectedness for them to be cited. Okay, and just to restate and to conclude, we do document a significant effect, although small but robust, of social connectedness on citations. And this is not just robust to physical geography and professional networks, but also on a set of robustness checks that I will be happy to discuss if there are any questions. So the interquartile range change would correspond to roughly a 1.2 percentage point increase in probability of citations. And again, this effect also depends on circumstances, which I'm not going to restate. And in terms of limitation, I should emphasize there are certainly some leftover measurement issues. There's literature discussing and evaluating the strategy of using examiner-added citations. And importantly, it's also difficult for us to distinguish between knowledge transfers from pure spillovers, which is something we'll leave for further contributions. And this is all I have. Thank you so much. Maybe I'll stop sharing the screen.